Hey YouTube, Solkill here, and there are lots of things that are so small that we are not able to discern them with the naked eye, and so thus we would just assume that they are all the same size before we start to come up with science and microscopes to have the ability to look at objects that are smaller than the angular width of the naked eye. Anyway, the point is, there are lots of things that are so small we can't see them, but the smallest of them all is the Planck length, except the Planck length isn't technically a physical thing, it's just a description of the smallest possible size. The smallest thing technically is the electron neutrino, a tiny elementary particle that's still a quintillion times larger than the Planck length, which is an unimaginably huge number, by the way. But why is the Planck length the smallest number? Well, there are two main reasons for this. The first is that the physics of our universe, or the quantum physics at least, just doesn't work below it. In fact, I need to make a video on this. There are two types of physics in the universe. There's quantum physics for tiny objects we can't see, and then there is almost a more classical physics style regarding gravity that is used for macro objects, i.e. everything we can see and everything around us and large objects. And these two don't actually work with each other perfectly, but if they could, then that would solve the entire universe. But anyway, the equations for quantum physics just don't work below the Planck length, which is 1.6 times 10 to the negative 35 meters, which is just so crazily tiny you can't ever imagine it. But another thing is, the main reason why the Planck length is the smallest size is because you physically can't see anything smaller than it. Why is this? Well, in order to see smaller and smaller objects, you need to fire higher and higher energy beams of light at these objects, which means their wavelengths get shorter and shorter, because we are looking at objects with visible light, but that won't cut it to look at something as small as the Planck length. You'll need to shorten the wavelength until it becomes something like gamma rays, which of course can cause cancer. But anyway, these gamma rays can then get so concentrated when you apply enough of them to see an object smaller than the Planck length that they don't actually end up showing you anything smaller than the Planck length. They come together instead and form a black hole. This black hole is known as a Kugelblitz, and so if you try to look at something smaller than the Planck length, this black hole would rip you up in an instant.